lot to accomplish, and I figured what better way than let's start the day off productively, take some notes, do a little bit of studying about something that I am passionate about. So I can't think of a better way to get my day started, So last time we took notes, we learned about fixed end, free end polarity. Let's just start off and jump right into it. So our first new definition for acoustics is superposition. Let's see. The principle. Oh, I spelled that way wrong. Still warming up, right? Still getting into the day. Principle of superposition. Let's see. Waves may meet space. Their displacement patterns. Also known as their amplitudes. I think we talked about amplitude a few videos ago. Maybe at this point, amplitude more so just being like, well, let's look at the raw definition. I bet we have it. Here we go. Amplitude, how high and low a wave, being a sound wave's oscillations are. So, how extreme this wave is. So their displacement patterns or their amplitudes may meet and be combined. And then separate with characteristics intact. So we have two waves. They'll meet and then they'll disperse on their own again. And this actually results in one of two results. This can be constructive or... Do y'all hear that? It's never a boring day in the city, I suppose. So this can either be constructive interference. So constructive meaning that the waves combine to be basically a productive outcome. So if we have both waves combining, they'll meet and then they'll create a bigger wave, hypothetically combining both of the waves into a wave that's twice as big, we'll say. So that's constructive interference. A greater amplitude is momentarily constructed, or this is destructive interference. Destructive interference. And all that means is that the two waves meet, and then because of their opposite patterns, they hit and less noise is created as opposed to more noise. Let's see. Amplitudes. Cancel each other out momentarily. waves, resonant frequencies, and harmonics. So what that means... a standing wave. Let's see. So now we have we'll do a little doodle right here. And actually, let's just go ahead and go to the next page. So we have standing wave. This wave does not propagate, but rather oscillates in one place. This wave will have equally spaced points that remain motionless, called nodes. These nodes are equally spaced points that remain motionless. Along nodes we have anti-nodes. These are the halfway points of a node in between two nodes. That is the maximum height or the maximum. Well, I guess it would be height at the top or the bottom. We'll say halfway between nodes at max, top or bottom. Let's see. Oh, we're getting a little complicated here. So a fundamental frequency. Let's start here. Fundamental frequency is the lowest frequency let's say object can support. Support is a good word. Support. From here we have let's say frequencies. Okay, so we have characteristic frequencies or resonant frequencies, and these are a set of frequencies that produce standing waves. That produce standing waves are characteristic frequencies or last definition for today is our harmonic series, which is a set of frequencies that are based on integer multiples of the fundamental frequency. So all that means is that a harmonic series, forgive me, I'm not going to remember the exact numbers, but like, let's say you have 2, okay, a multiple of 2, you'll have a frequency spike at 2, and then you'll have a frequency spike at 4, and then you'll have a frequency spike at 8, and then you'll have a frequency spike at 16, and so on and so forth. So when you're hearing a frequency, hearing a noise, let's say a trumpet plays or an instrument plays, we'll say, you hear that initial frequency, and then later on in the thousands of frequencies you hear smaller ones, so you're not hearing one note, you're hearing a series of notes, and that gives that note body. So that's all we have for today. Let's see, what did we do today? Today, we talked about superposition. That's when 2 waves meet together on a line. If you have a guitar string, let's say, you have a note here. If this one's down here and this one's up here, they'll meet, cancel each other out momentarily, and then leave their way. That'll be destructive interference. Cancel. And then they come back and leave. Or if you have constructive interference, you have 2 waves. They'll meet, get a spike, and then they'll head their way again. So that's the idea of superposition. And then we learned about standing waves, waves that oscillate independently instead of, what's the word? Oh, I'm gonna forget it now. Uh-oh. A wave that oscillates as opposed to propagates. So as opposed to propagating, this wave oscillates. And then through each interval, like regular, you have nodes. And then halfway in between those nodes, you'll have a peak. That'll be an antinode. A fundamental frequency is that frequency that object provides. And then a harmonic series is the harmonics of that fundamental frequency. So, with that being said, that's all I have for today. If you guys stuck it out this far and listened to me, I appreciate you having me in your day, and I hope to see you